Next we have Mark Shirley from Eva. Mark, someone that we've come to rely on actually very heavily in the magazine over the years because of his particular expertise with regard to energy consultancy and airtightness in construction with regard to Pardell, which is what we'll be talking about today. He's a BSc in Energy Management of Buildings and has worked as an independent energy consultant since 2008. BR assessor, one of the best I've certainly come across, and as such has an in-depth knowledge of DEEP, the software used to calculate compliance with Pardell in Ireland and generate BERs. He's an NSAI registered air leakage tester and a certified passive house tradesman, and is the invited Irish representative member of the European Airtightness Association Committee, and his company is one of the few in Ireland with the capability to perform airtightness testing on commercial and industrial buildings. So, thanks Mark.
Thank you, Jeff. I hope I'm not rushing. So, good afternoon, everyone. Thank you to Heat Merchants for inviting me to come along here today and discuss airtightness in buildings and the influence on Pardell. I'm going to give you some background to DEEP, to Pardell and how DEEP works in Pardell, and explain how airtightness is achieved on site and how it's actually a very inexpensive way for you to be compliant and to improve, for example, your BER. So this is the document that I'm sure most of you will have seen. This is Pardell of the Building Regulations, which deals with the energy, the conservation of fuel and energy in dwellings. This is not a document that you need to know intimately, but you need to know somebody who does know it intimately. Okay? We came up with an expression, I suppose, in conjunction with Jeff's brother, which we call let's take the hell out of Pardell, and we'll see in the next half an hour or so if we can make things a little bit clearer for people. So Pardell of the Building Regulations deals with the building fabric, insulation, thermal bridging and air permeability. Building services. The current building regulation that you must show compliance with is the 2011 version. So there was also a version in 2008, but the transition for that has expired. All of those transitional arrangements, regardless of when the building you're intending to construct either achieved planning or you applied for planning, have expired as of the 30th of November. Okay, so anything you're looking at now must be built to 2011 Pardell. There will be a new 2011, there will be a new Pardell, I think, out towards the end of next year, early part of 2016, and again there'll be a transitional period in place. But what we're going to talk about today is about what you need to do now. There has, unfortunately, been a lot of confusion about that. Some people have started construction and expected that the building had to be built under the 2008 Pardell and had done all their calculations to come in under that criteria. 2011 Pardell is quite a bit more onerous than 2008. So in Part L it will tell you how to achieve overall compliance and how you prove it. And it says the methodology for calculation to be used is specified in the regulation as the DEEP methodology. Okay? So, what is DEEP? The Dwellings Energy Assessment Procedure, or DEEP, or DAP as some people call it, is the national methodology for calculating and assessing the energy performance of dwellings. So just to be clear here, because there's a lot of people, for example, including myself, who would be involved in passive houses and who are very keen on other types and forms of low energy buildings being constructed. And there's various types of calculation methodologies for those buildings, but only DEEP can be used at the moment to show compliance with Pardell. It was devised and is upgraded by the SEAI, the Sustainable Energy Authority of Ireland, my overlords. So, again, DEEP can be a little bit confusing because people tend to think of DEEP as this all-encompassing calculation. It actually takes into account the energy required for space heating, ventilation, water heating and lighting only. Less savings from energy generation technologies. So whilst we might sit down and take 80, 90, 100 inputs into account, it's really those 4 things that it's working on. Lighting, I suppose, has become less and less of a contentious issue because the vast majority of lights now being installed in buildings are low energy lights, and quite possibly when they revise DEEP at some point they're going to take the lighting out. It has, if you go into a building, the lighting alone can account for quite a substantial part of the calculation, probably far too great a part in reality. So DEEP is often seen as a not a perfect tool. It's very difficult for it to be a perfect tool because it takes into account every type and size of new and existing dwelling construction. So it's very difficult to have one software tool to manage all of that. It's constantly being upgraded. We constantly get technical bulletins on it to confirm how things should be treated. And as new technologies come along, we are, I suppose, brought up to speed with the new technologies, things like PV, when they came in, heat pumps and so on. So it's a never evolving landscape that we're dealing with. So typically we would start off by measuring a building and preparing the inputs to go into the actual DEEP calculation itself. So this here, this is a snapshot of what DEEP looks like, and we would take our own calculations then and enter them into DEEP. If you don't use DEEP regularly, I'd advise you not to use it. It's not rocket science by any means, and it can be used in a practice to help ensure that the building you're designing is going to be compliant with Part L. But like any piece of software, whether it's a word processing document or Excel or whatever it might be, if you don't use it regularly, it will confuse you. There's a lot of things that happen when you make an entry on one tab that have impacts on the other tabs down here, and unless you use it regularly, you won't be aware of it. Under the recent Building Control Act, the certifier must have supporting documentation to show compliance with the various parts of the regulations. And in the case of Part L, this is proven through the DEEP calculation. So it's becoming more and more common that at the time of commencement notice, Part L calculations are required to be submitted, which shows the stated intention of the builder or developer that when the building is built, it will be compliant with Part L. Now, it's not uncommon that we will do a Part L calculation with one type of technology and another type of technology might be used. But as long as what you start off with your stated intention and you finish up with a building that is compliant, that's the most important part. What you have to have when you do a Part L calculation, this is effectively the final sheet, the result sheet. It doesn't say in the building regulations that you must achieve, for example, an A3. Okay, that's not stated in the building regulations. But by default, if you build a new building to the current building regulations, you will have no less than an A3. I would be very dubious if anyone presented a B1 to me and tried to convince me it was compliant with Part L. So you could argue that the A3 is the least that you're going to see on any building currently being constructed. Each band, you see a figure here, so an A3 goes from 50 kilowatt hours up to 75 kilowatt hours, and an A3 can be anywhere in there. And sometimes when the calculation is done, we're quite close to an A2, and then the customer can make up their own mind. If for marketing reasons or some other reason that they want to get an A2, we can give them advice as to how to get into an A2. But most importantly, the key to all of this is that you have to have these 3 green ticks. And if you don't have that, you can't prove compliance. And it gets flagged up in what we call validation when we go to upload the certificate or the file to SAI, and it will warn us that the building is not compliant and that we are obliged to inform our client. And obviously we couldn't give a Part L compliance report for certification in that case. So the 3 parts that we saw earlier, the 3 green ticks, there's the Part L renewable contribution, which is 10 kilowatts per metre squared per year. Again, a lot of people are under the impression that's 10%. It's not, it's 10 kilowatts. It's a straight line value. And that can be quite difficult. If you build an extremely energy efficient building, it might naturally have a requirement for 10 kilowatts per metre squared per year in total. So it can be quite difficult sometimes to prove that if people are really going to the nth degree in energy efficiency. Now, that is designed or called a reasonable target, I think is the way it's expressed in a reasonable proportion. Thank you, Jeff. So, in theory, it is actually within the remit of the building control officer if you build an extremely energy efficient building that doesn't require 10 kilowatts per metre squared per year. I'm going to say, for example, we're only achieving 3 or 4. It is within the remit of the building control officer to accept the report with less than 10 kilowatts. It would be a very unusual situation. But the two major, or the two other ticks then that you have to have, the two green ticks, relate to your carbon performance and your energy performance. As a general rule, as you build up the calculation, you put your inputs in and you put your various technologies in, I would expect that you will be below your carbon threshold. The really, really difficult one to get across the threshold at the moment is the energy performance threshold. It's getting to the point where it's almost impossible without adding a huge amount of renewable energies or other types of systems to build, for example, a one-off house, typically in the country, with an oil boiler. Sorry, Ferbert. It's possible, but you really have to work at it with the client, and generally the client's not too happy about what we have to do to get it compliant. So the houses that you're building now are something in the order of 60% more energy efficient than they would have been in 2005. And I'm sure you're all aware of that because you're the ones who are seeing the level of insulation that are being put in, the quality of the windows, the types of heating systems, the controls, all these various things, and obviously including the air tightness. So since 2008, every house that's built must have an air leakage test. I won't ask for a show of hands of how many people built houses since 2008 that didn't have an air leakage test. I suppose we bring in regulations in Ireland and control has to get caught up with it. So when the department brought in the building regulation in 2008, the target was 10 cubic metres per metre squared per hour. Now, without blinding you with all sorts of stuff, the level of 10 as it was then and the level of 7 now is actually very easy to achieve. So no one should have any fear of having an air leakage test done and trying to achieve these values. They're not difficult to achieve. In fact, it's quite an interesting part of the human psyche when we started going out and doing air leakage testing in 2007, 2008. Because the level was so high, everyone passed. Now you might laugh at that and you might think, well that was kind of crazy or a waste of time. But what it did was, it allowed people be given a challenge and get over the challenge, and coincidentally or funny enough, as we went out to do subsequent tests, they were always trying to beat the last test result that they got. And the beauty with air leakage testing is, it's a very tangible thing. It's not like me putting a load of math and science up on the board and telling people, well, you failed. If you go out to a site and you're not achieving a good value or the specified value, there's a reason for it. And we'll always find a reason. If we depressurize the building, for example, and we pull air out of the building, that air is being replaced through the cracks and gaps. So as we walk around with the builder, you're either going to see the problem, you'll see insulation maybe waving in the air that's coming in, or a bit of dust swirling, you'll hear it. So if you get a weak seal on a window or at an attic hatch, you'll hear a whistle, and most commonly you'll feel it. Now obviously we can use things like smoke tests and thermography as well to identify with it, but in 95% of the cases you'll find 95% of the leaks just by using your experience. And once you can show a builder where the problem is, then they can repair it. So it's a very tangible thing. The trick when you're building multitudes of buildings is to get into a methodology so that you're not repeating the same mistakes over and over again. So for the purposes of your deep calculation, you take the test result and you divide it by 20, and that goes into your calculation. So for example, the backstop value, or the maximum upper limit that you're allowed to use under the 2011 regulations, is 7 cubic metres per metre squared per hour, and you divide that by 20, so the input will be 0.35. And this is what's called the air permeability rate, that value, cubic metres per metre squared per hour. So what's an air permeability rate? In Ireland, for many, many years, I suppose, because of the ventilation industry, the expression air changes per hour was very common. And it's still quite common that specifiers will mix up this expression between air changes per hour and the air permeability rate. Even more so when people are talking about passive houses, because the passive house has a specific target that the air change rate in the house on completion must be at or below 0.6 air changes per hour. Okay? So whilst these values are different, we're talking about one value at 7 and one at 0.6. Okay, so there's a huge difference there, we'll try and clarify that. So air changes per hour is the relationship between the total volume of air in cubic meters and how often it leaks through the building envelope at 50 pascals pressure in a given hour. I've lost some of this. However, this is not what you need for Irish building regulations. Even though it's a very commonly understood expression, for Irish building regulations, we have to talk about the air permeability rate. And the air permeability rate is very simple, very simply, the amount of air that leaks through the envelope of the building, through the floor, the walls and the ceiling, and includes the party wall in a semi-detached house at 50 pascals pressure. And that's measured so that we install an air leakage testing device, the fan runs, we put in the inputs of the building, and we get a result. Obviously that result has to be less than 7 cubic meters per meter squared per hour, or it has to be in line with the target that's been specified by the architect or maybe your energy consultant. So we often get asked, do you have to test every building? And this is kind of a loaded question. Yes and no. If you're building a multitude of buildings, there's a sample regime that you must test to, providing you use the backstop value. So if you design your buildings and you design your deep calculation to be compliant with Part L, and you're using that figure of 7, you can use the table that's on the screen, it's in the building regulations. Okay? However, since 2011, in the new regulations, if your energy consultant is using a value less than the backstop value of 7 cubic meters per meter squared per hour, or 0.35 is the input, you must test every single dwelling. Okay? So, as a BER assessor, even if you're using the backstop value, you have to say that the test has been done. It's a little bit of an anomaly in the software that SEI are probably going to fix. So if you're using the backstop value, you say yes, but if it's better than 0.35, you must do a test on each and every building. Now what we're starting to find is that more and more of our customers are actually starting to use air leakage testing as a quality control tool, which is really what it was designed for, to check not just the air tightness of the building, but the overall performance of the trades on site. You could argue that air leakage testing is really an empirical value on the quality of the construction, because it really does show if the tradespeople on site have done what they were supposed to do, or more importantly, haven't done what they were supposed to do. Really, this is about the collective work of all the trades on site and the care and attention, and that's why, in reality, it's not expensive to achieve a good level of air tightness on a site. Really, all you're asking the tradespeople to do is to do what they should be doing, which is to pay due care and attention and build correctly. Well, so where does air leak? Well, the common locations, I'm sure you're not surprised with this: windows, skirting boards, hot presses, any plumbing penetrations, electrical penetrations. You know, it's a lot of people would do first fix tests on a building, air leakage tests, when they're starting a new scheme, so they can get their head around air leakage testing and where do leaks occur. And sometimes we'll go in and we'll do a test and we'll get a value and it's very acceptable. And when we go back to do the final test, it's far worse. And the problem there is that the tradespeople have come along and have taken, for example, a craft knife to an airtight membrane or an airtight tape that was on a window. They're there to do their business or their job, and they're not aware or not concerned about the people who went before them and the people who are going after them. This will always be found, and what you'll hope is that you catch it early enough that you can change that behaviour on site. Over the last 5 years, 6 years, 7 years, we've all suffered with a very poor industry. But because of the poor industry, what's happened, in my experience, is an awful lot of people have gone back to school. Very common to go on any kind of training course now, and you'll meet various trades. So the skill sets for achieving air tightness, and even though air tightness mightn't have been the specific training course, it probably was part of a training course, the skill sets have improved greatly. The materials are now available. There's a number of different manufacturers and suppliers of materials. Manufacturers like some of the window manufacturers, 5 or 6 years ago, if we went out and we tested buildings, it was very common for windows to leak. It's the complete reverse now. It's normally the windows are one thing that you can almost bank on now, that the windows themselves, not the junction between the wall and window, but the actual windows themselves will be airtight. Having said that, if you go out and you test a building and there's 3 or 4 windows leaking or 5, typically they'll all be leaking because they're a manufactured component. They're either made right or they're made wrong. But to be fair to the window manufacturers, they've risen to the challenge. So again, without any huge cost or excessive investment, it's very easy to get to the backstop values, and certainly nothing that you should be scared of. So where do you start off with? You start off by making a building airtight, by designing it to be airtight, by being cognizant of where the leaks can occur, and by taking steps at the earliest stages and continuously through the construction to keep it airtight. So define where the airtight layer is, define what is going to be the line of our airtightness in the building, and discuss with the trade so they can work with you to make sure that it's done properly and that it's the continuous airtight layer is not broken. Again, if you're building a building and it's been specified to have, for example, something like a mechanical ventilation system with heat recovery, best practice would dictate that you would do 2 air leakage tests, certainly until you get to a point where you're comfortable that you know that everyone is working the way you want them to work. After maybe 2 or 3 buildings, that first fix test is probably not required because you yourselves will get your own eye for airtightness as you walk around the building. The school of airtightness is literally by doing things on site yourselves. And you'll walk into a building after you've done a couple of air leakage tests and you'll be able to spot where the problems are before we turn up. So if you're trying to get down in the first couple of houses to a very low level of airtightness, I would suggest, without trying to force you to spend money, to get 2 air leakage tests done, because what you find at first fix stage can be very easily fixed and very inexpensively fixed. Whereas if you wait till the end and you're above the values that you're trying to get to, then it starts to get expensive. It's also at the point where you're trying to either sell the house or someone's trying to move into it. And it can get very awkward. Important to remember here though, is that only the air leakage test on practical completion is valid for your BER. So I'm aware of situations where people have, for example, built timber frame buildings or get a test on first fix stage just for quality control, and they were of the understanding that that test was valid for the BER. It's not. It's only the one on final completion. This is a device that we designed and we get manufactured in Portlaoise. It's called a Zephyr Pre-Pro. So the Pre-Pro, as the name would suggest, is before the professional arrives on site. And it's very simply a fan that depressurizes the building. So we're standing on the outside of the building now, so the air will be coming towards us. And there's a gauge on there so you can see what the pressure difference is inside in the building. So when you turn the fan on, it pulls air out of the building, and that air is being replaced through the cracks and gaps. And it allows the builder or the trades on site to go around the building, to take their time and find where the cracks and gaps are, and obviously then to repair them. This will do 2 things. It gives you time to do this within your own scope of build, that you're not under pressure to do it. But it'll also help you to maximise the result once the actual tester turns up. You're going to be 95% certain that all of the cracks that the tester's going to find have already been found and taken care of. There's one out in the foyer if you want to talk to me afterwards and have a look at it. So, 4 things to remember about airtightness. You must test either sample or all of your houses. Okay, so take that away and look at the specifications that you have in your BER. If it's less than 0.35 in the calculation, you're possibly going to have to test every house, or look at, can you get the calculation redone, if that's what you want to do, but you're still going to have to test the sample regime. The test must be done by an NSCI certified air leakage tester. So when your energy consultant or BER assessor gets the air leakage test, he will not be able to input the value unless it's done by an NSCI registered tester. Only the test on practical completion is acceptable, and the test results are used indeed to improve your BER and to confirm compliance with Part L. So as a BER assessor, as someone who does Part L calculations, you're trying to tweak all of the things in the calculation in recognition of the cost that's involved to do it. And I've seen cases where, because people maybe misunderstood what was involved, they've cranked down to a very, very tight level the expected air leakage test, and they haven't understand A, how difficult it is to get down to passive house levels, for example, in a standard 3-bedroom semi-detached house, where no one had any experience of air tightness on site, and didn't understand the implications that when you're down to that level, you must have mechanical ventilation. So you had two parts of the building regulations competing with one another. So that can create its own problems. Thank you.